Good morning, everyone. Myself Disha, my teammates are Gnaneshwari and Aryan, and here we are going to explain about Firefly algorithm, which is a nature-inspired optimization. Now, now, before we go into the mathematics, let's understand the nature inspired behind it. In nature, fireflies communicate using a light flashes. The brighter a firefly is, the more attractive it becomes to other fireflies. So, naturally, fireflies that are dimmer will move towards the brighter ones. Similarly, in this algorithm, each firefly represents a solution. The brightness represents the quality or fitness of the solution. A poor solution will move towards a better solution. Just like how fireflies attract each other at night, in the algorithm, better solution attract weaker ones until the population gradually moves towards the best solution, best or brightest solution. For example, imagine fireflies in a dark forest. One is glowing very brightly. This represents a very good solution. Naturally, the other fireflies start moving towards it. As they move, they may discover even brighter points. So finally, most fireflies settle around the best optimal solution. The firefly is a population based and stochastic optimization method. That means instead of searching for solutions individually, it uses a group of fireflies working together. Similarly to swarm optimization like ant colony or particle swarm optimization. Here, each firefly is a possible answer for optimization problem. Now, how do we measure whether one solution is better than other? We use something called the objective function or fitness function. The brightness of a firefly depends directly on the fitness value. For maximization problem, higher value is equals to better firefly. So for minimization problem, lower value is equals to better firefly. So the rule is simple. Brighter firefly is equals to better solution. Dimmer firefly move towards brighter firefly. For example, suppose we are trying to find the shortest route in the Google map. So it's a maximization problem. The firefly with its shortest path is the brighter one, and all other paths will move closer to the improve themselves. Once we understand the concept, we convert it into the mathematical form. The attractiveness between two fireflies is given by beta is equals to beta naught into e to the power minus gamma into r square, where beta naught is the attractiveness when two fireflies are at zero distance. Gamma controls how quickly attractiveness decreases as distance increases. R is the distance between two fireflies. Meaning, if two fireflies are very close, attraction is strong. If they are far apart, the attraction decreases just like light fading over distance. Next is the moment equation. That is xi is equals to xi plus beta into xj minus xi plus alpha into random minus 0.5. Breakdown in simple language is the firefly moves towards a brighter one based on how attractive it is. The last term is alpha into random in minus 0.5 adds randomness, so the algorithm explores new possibilities and doesn't get stuck. For real life analogy, that this is similar to how humans improve skills. We learn from someone better than us, but we still add our own creativity and experimentation. So overall, the Firefly algorithm works by combining imitation and exploration to reach the best possible solution. So next, Gnaneshwari will continue the PPT.
Hello everyone. Now let's understand the overall working process of the Firefly algorithm. The primary step is initialization. First, we create a group of fireflies. Like each firefly is a random solution. So with the including with the three parameters, that is alpha, beta, and gamma. And the step two And the step two is evaluate brightness. Now we calculate the fitness value for each firefly. The fitness value is decided based on the like minimization problem and the maximization problem. If it is the minimization problem, lower value is lower brighter, and the maximization problem, higher value is the higher brighter. Step 3 is attraction and movement. Each firefly compares with other fireflies, find who is better and move towards that firefly. So the movement is based on attractiveness, distance and randomness. The fourth step is updating the population. After moving, we check the position improves the solution. If the position improves, it replaces with the old solution. If not, it keeps the original and the updation or is noticed. So the next algorithm flow is look like initializing the fireflies, evaluate the brightness for each fireflies of I and for each fireflies of J. If I is lesser than J, and the I value move towards the J. If I value is greater than J value, add the random movement. Next, the updation of the position and the fitness value will be updated. And if the topic condition met, it ends. So the next is iteration process. Iteration process. The pairwise comparison. For every firefly I, we compare it with the firefly J. If J is brighter, I move towards the J. So next, light absorption. The light is not constant. As the distance increases, attraction gets reduced. So the movement updation. The movement is based on like two movements: direct movement and the random walk. Next, the evaluate of the new brightness. Like after moving, like we recompute the fitness value and the updation of the brightness will be done. So this continues until the maximum number of iterations will be done. So next, Aryan would like will continue.
So yeah, now I will start with the key calculations. So here we analyze the distance between two fireflies based on their positions. So here Rij equals to summation of xik minus xjk whole square. So what is here? I is the firefly number 1 and j is the firefly number 2, and we have to calculate the distance between the two fireflies, and k is the x coordinate and y coordinate for each of the fireflies. Suppose the x and y positions of firefly 1 is 2 and 3, and those of x and y coordinates of firefly j are 4 and 1. So the distance between them will be the square root of 2 minus 4 whole square plus 3 minus 1 whole square. So distance calculation is done to know how far two fireflies are, and attractiveness calculation is to determine how strongly one firefly moves towards another, and movement calculation is done where the firefly updates its position. So mathematically, every movement is guided by brightness but also includes randomness to prevent getting stuck in local optima. So now here we have for brightness calculation for maximization, we have I is directly proportional to fx. So here I is the intensity and fx is the value of the objective function at a given solution. Brightness is equal to quality of the solution, where higher brightness is equals to better solution and lower brightness indicates worse solution. So now I will explain about the analysis. So F1 movement, for F1 move toward the brighter firefly F2, but the random walk component has a slightly stronger effect than the attraction term. As a result, F1 moved away from the true optimum at 0, 0. This increases its objective value, meaning its intensity becomes worse. And for F2's movement, since F2 is already the brightest firefly, it performs a random walk. The random step moved is slightly away from the optimum, causing its intensity to increase from 2.0 to 2.164, indicating worst fitness. And the best solution after this iteration, the best solution is still F2's initial position with intensity I best equals to 2. After one iteration, we compare initial and final results. We notice that the values are now closer to the best solution, showing improvement. With more iterations, the fireflies will converge to the global optimum. The interpretation indicates this single update steps highlight the main idea of firefly algorithm. The attraction term encourages fireflies to move toward brighter positions. This indicates exploitation, and the random walk term helps them to explore new ideas to avoid local minima. This is exploration. So now I will explain about the advantages. So the advantages of Firefly algorithm are as follows. They are easy to implement, few equations and simple parameter tuning, and these are excellent global. They have excellent global search ability. Naturally, Firefly algorithm avoids local optima through attractiveness mechanism and randomized movement, and they perform automatic subdivision of the population. Brighter fireflies attract others, forming multiple subgroups that explore different regions simultaneously. And they have very few parameters to tune. Suppose here beta naught, that is attractiveness at r equals to 0. They are self-adaptive and parameter-free behavior. The algorithm automatically adjusts exploration versus exploitation. The fireflies which are far away, they indicate large random steps, that is exploration. And the fireflies which are nearer, they indicate small attractive moves, that is exploitation. So there is one more advantage, that they have robust and stable performance, less sensitive to initial population than many algorithms, consistent results across multiple runs due to balanced exploration or exploitation. So now I will talk about the applications of the Firefly algorithm. So they are used in mathematical optimization. So, the Firefly algorithm is widely used to apply various optimization problems, such as nonlinear equation solving, multimodal optimization, constraint optimization, global optimization tasks, and multi-objective optimization. Here are the major applications of the Firefly algorithm, such as image processing. This includes image segmentation, image compression, image enhancement, edge detection, and medical image registration. And in machine learning and data mining, they are used for machine learning operations such as clustering, neural network training, hyperparameter tuning, classification rule mining, and feature selection. In scheduling and planning, they are used for job shop and flow shop and vehicle routing problem. For structural engineering, they are used for truss optimization, beam design, material selection, and shape and topology optimization. They are also used for hybrid and improved variants. Commonly, they are hybridized with genetic algorithm, particle swarm optimization, and ant colony optimization. So that's all about the applications of the Firefly algorithm. Thank you.